All right, then we get into a couple business related functions. So a couple definitions to talk about here. They give you the cost function and they also ask questions about what's called average cost. So think about first, we'll do this part A and B, and then we'll get to the how we can turn it into a whole function. So part A is the cost at a production level 1100. So we have an equation where we put in the number of units and it spits out total cost. So we just plug 1100 in and we get 4290.09 if we plug 1100 into this function. Suggest just doing that in your calculator. No need to do it by hand. All right, then part B wants the average cost at a production level of 1100. All right, so picture what average cost means. This is the total amount it costs to make 1100 units. Average means how much does it cost for each unit, right? What's the average across those 1100? So you take your total cost and divide by the number of units you made. And so the average cost per unit is 3.900086. Probably get away with rounding to 3.9. I think they say 3 decimal places or something in the answer. So like about $3.90. All right, if we want to think about that as a function, because it's going to come up later, picture what we just did. We just divided the total cost by the number of units, which is x. And so back here at the function step, if you want to make an average cost function, and you sometimes see them put a little line over it to show that it's average cost, you divide your whole equation by x, because this is your total cost divided by the number of units you made. So just like we did with dividing by 1100, except for here, it works no matter what, right? We don't know what the actual function is. If we want to cancel some of this stuff out right now, if we're dividing by x, we have x to the 1/2 divided by x. So that'll leave square root of x on the bottom, or you can think of it as x to the negative 1/2. Right, 1/2 divided or subtract, cancels out with one of them. So 1/2 minus 1 for the exponents. And then the x squared will cancel, so you're just left with x over 27,000. So if you have a cost function, here's your average cost function. Just divide by x. All right, then they also asked a question about marginal cost. Marginal means essentially like the slope of cost. How much does it cost to make the next unit? And if you want the slope of a function, that's the first derivative. And so in this one, we have 128x to the 1/2. So that's what? 114, 50, 64. Right, 128 times 1/2. X to the negative 1/2. And then we have 2x over 27,000. Right, the derivative of x squared is 2x. Although if you want to reduce that fraction further, that's 1 over 13,500. Right, they're both divisible by 2. So just taking the derivative of our original function. All right, then they ask some questions, some specific points here. They say, what's the average cost or marginal cost at a production level of 1100? So that just means plug into the marginal cost equation. That one gives you about $2 and a little bit more than 1 cent per unit. So that means how much it costs to make the next unit if you're already making 1100 of them. Like how much does that 1101 or 1101st unit cost you? All right, and then the production level that will minimize the average cost. So here's why having them labeled is helpful. We want to minimize this one. Then notice from all of our other from all of our other ones. How do we minimize something? We take the derivative, first derivative, and set it equal to 0 to find critical points that could be maximum or minimums, and then we figure out if they're a maximum or minimum. So I'll erase the other equations because we're just focusing on this one now. They want us to minimize average cost. So we want the derivative of average cost. So negative 1/2 times this is negative 64. Negative 1/2 minus 1 is negative 1/2, or negative 3/2 is a fraction. And then this is x to the first. Don't forget it's 1 over this 27,000 number. And so x to the first, the derivative is just 1. So you're left with 1 over 27,000. Or if it's easier to see, like back here, 27,000 is just 1 over 27,000 is just a coefficient. Because it's a fraction, it sometimes looks nice to write it in the front. But like think derivative of 3x would be 3x. Derivative of 1 over 27,000x is 1 over 27,000x. All right, so now we want to set this equal to 0. So I'd probably subtract this 64, add the 64 thing to the other side. So 64x to the 3/2 equals 1 over 27,000. And then I could divide both sides by 64. So 1 over 27,000 divided by 64 is 1 over 172.8 with 4 zeros. No, 3 zeros. I wish they had commas on the calculator sometimes. So 1 over 1.7 million-ish, 27,000 times 64. All right, then we want to get rid of to the 3/2. So think if you have to the 1/2, right, a square root, you can square both sides. If you have a third, you can third root both sides. If you want to be able to do the whole thing at once, save yourself some time here. If I put both sides to the 2/3, picture why that would work. 3/2 times 2/3 is 1, right? 2 over 2 cancels, 3 over 3 cancels. So you end up with x to the first equals, which was our whole goal anyways. So 1 over 1,728,000 to the 2/3 power. Oh, sorry, and this was negative. Make sure I copy it down correctly. So that makes that one negative. It needs that to be negative, which works out kind of nice because it'll give you the reciprocal of this. So to the negative 2/3 power gives us 114,400. All right, picture what that's saying in the context of the problem, because x is the number of units we're making. This is the number of units we should make in order to minimize the average cost. So this is the optimal number of units. And then they say, what is the minimum average cost? Well, we have an average cost function. So essentially we know the x of that point. We want to know what's the y at that point. So if I just plug 14,400 into my average cost function, and certainly do that in your calculator, right? No reason to. So this is like 128 over the square root of 14,400 plus 14,400 over the 27,000 gives us like 1.6. So that's the average cost per unit. That's the lowest that we can get our average cost per unit. We minimize the function.